Ever looked at a plane's speed on the in-flight map and wondered, what on earth is a knot? Or maybe you've heard sailors talking about their ship's speed in knots and thought, why not just use miles per hour like everyone else? It seems a bit old-fashioned, right? Well, there is a fascinating and very practical reason why the worlds of aviation and maritime navigation stick with this unique unit of measurement. And today, we're going to unravel this mystery together. It's a story that connects ancient sailors, the very shape of our planet, and the high-tech navigation systems we rely on today. So, get ready, because by the end of this video, you'll not only understand what a knot is, but you'll also appreciate the genius behind it. First things first, let's define what a knot actually is. A knot is a unit of speed equal to 1 nautical mile per hour. Okay, great! But that just raises another question. What's a nautical mile? A nautical mile is slightly longer than a regular mile, the kind we use on land, which is officially called a statute mile. 1 nautical mile is exactly 1,852 meters, or about 1.15 statute miles. So, if a ship is traveling at 20 knots, it's moving at about 23 miles per hour. That difference might seem small, but over long distances, it adds up significantly. The key to understanding why they use this special mile, and therefore the knot, lies in how we map our world. Our planet is a sphere, or more accurately, an oblate sphere. When we try to represent this curved surface on a flat map, distortions are inevitable. You've probably seen a Mercator projection map, the one where Greenland looks enormous and Africa seems smaller than it is. While it distorts size, the Mercator map has a huge advantage for navigation. It keeps lines of constant bearing, or rhumb lines, as straight lines. This means a navigator can draw a straight line from their starting point to their destination, and as long as they maintain that compass heading, they'll get there. This was revolutionary for sailors. Now, let's talk about latitude and longitude. These imaginary lines crisscross the globe, giving us a coordinate system. Lines of latitude run east-west, parallel to the equator, while lines of longitude run north-south, from pole to pole. Here's the brilliant part. The nautical mile is directly linked to this system. 1 nautical mile is defined as 1 minute of arc along a line of longitude, or any great circle. A great circle is any circle drawn on a globe whose center coincides with the center of the globe, like the equator. Think about it this way. A full circle has 360 degrees. Each degree is divided into 60 minutes. So, if you travel from the North Pole to the South Pole along a line of longitude, you've traveled 180 degrees. Since each degree has 60 minutes, that's a total of 10,800 minutes of arc. Because 1 minute of arc equals 1 nautical mile, the distance from pole to pole is 10,800 nautical miles. This creates a beautiful, seamless connection between the chart, the compass, and the distance traveled. A navigator can look at their chart, measure the distance between 2 points of latitude using the scale right on the side of the map, and know exactly how many nautical miles they need to travel. It's an integrated system that doesn't require complex conversions. Let's go back in time to see how this all started. The term knot comes from a very clever, low-tech device used by sailors for centuries called a chip log, or just a log. This wasn't a logbook. It was a piece of wood, often a wedge-shaped block, attached to a long rope. The rope had knots tied in it at very specific, regular intervals. To measure the ship's speed, a sailor would throw the chip log into the water from the stern of the ship. The wood was weighted to float upright and act as a drogue, staying relatively stationary in the water as the ship sailed away from it. As the rope unspooled, another sailor would use a sandglass, like a small hourglass, to time a specific interval, usually 28 seconds. When the time was up, they'd stop the line and count how many knots had passed through their hands. The spacing of the knots on the line was mathematically calculated so that the number of knots that passed in 28 seconds directly corresponded to the ship's speed in nautical miles per hour. So, if 5 knots went by, the ship was moving at 5 knots. It was a simple, yet ingenious way to measure speed at sea. This is where the name comes from. They were literally counting knots. So, why did planes adopt this system when aviation took off in the early 20th century? Many of the first navigators were former men. They brought their trusted tools and techniques with them from the sea to the sky. The principles of long-distance navigation are fundamentally the same, whether you're on water or in the air. You're traveling over a curved Earth using charts based on latitude and longitude. Using nautical miles and knots meant that all the existing maritime charts, tools, and calculations could be used directly for flight planning without any need for conversion. Furthermore, air traffic control and international regulations for both air and sea travel are standardized around the knot. Imagine the chaos if a pilot from one country was reporting their speed in kilometers per hour, another in miles per hour, and air traffic control was trying to manage them both using knots. It would be a recipe for disaster. Using a single, universal standard ensures that everyone, from the ship captain to the airline pilot to the controller on the ground, is speaking the same language. This standardization is absolutely critical for safety, preventing collisions, and ensuring smooth, efficient management of crowded shipping lanes and airways. Even with the advent of GPS and highly advanced inertial navigation systems, the knot remains the standard. Your GPS might know your position to within a few feet, but it still displays your speed in knots because that S, the language of the system it is part of. The entire global infrastructure of navigation is built upon the nautical mile. It's deeply embedded in the software, the charts, the procedures, and the training of every pilot and mariner. Changing it would be a monumental task, requiring a complete overhaul of a system that has worked perfectly for centuries. So, while miles per hour and kilometers per hour are perfect for land travel, where distances are relatively short and the curvature of the Earth is less of a factor, they just don't fit into the elegant globe-spanning system of navigation. The nautical mile's direct link to the Earth's geometry makes it the superior choice for anyone crossing oceans or continents. It simplifies calculations and provides a universal language for global travel. The next time you're on a flight and you see the speed displayed in knots, you can smile and know exactly why. It's not just some quirky old tradition. It's a tribute to centuries of navigational wisdom. A system so perfectly designed that even in our age of satellites and supercomputers, we haven't found a better way. It connects the wooden ships of the past with the jet liners of today, all tied together by a simple, brilliant unit of measurement. The knot is a testament to human ingenuity in our enduring quest to master the art of navigating our vast and beautiful planet. Thanks so much for watching and exploring this topic with me. If you found this interesting, please hit that like button and subscribe for more deep dives into the world around us. Let me know in the comments if you have any other why questions you'd like me to tackle. See you in the next video!